so today our learning objective is I can use deductive reasoning to complete a two-column proof. So let's see if y'all remember. Deductive reasoning. ¿Qué tipo de razón es esto? What type of reasoning is this? Is this reasoning with patterns and observation or rules and facts? Facts. Yeah. Great job, Simona. Rules and facts. So, I'm going to teach you now 4 different rules. And not 4, 10 different rules that we're going to use to complete a two-column proof. And then before we get into this, let me just explain what a proof is. A proof is a series of steps that explain how we come to a conclusion. So it's basically just doing something, but telling your why as you do it, telling your reasoning as you do it. What rule allows you to get to this conclusion? All right, so let me look at the time real quick. We have exactly an hour left in class. I am going to start a 30-minute timer. I want to be done in 30 minutes. And so what we're going to do is we're going to shortcut the front, and then if we have time, come back to it. All right. Just for the record, I am currently recording right now. So, please don't say anything crazy. Please don't make me have to edit this video. Also, let's keep our side conversations to a not happening type of thing. Y'all tend to do really great about that. I just wanted to reiterate. So, the first rule that we are going to learn is the addition property of equality. And so the addition property of equality, what this column is going to be is the definitions. And so the definitions are the super nitty-gritty, all right? They're the textbook explanations. The definitions probably will not make sense to you the first time, and that is okay. That's why we got, 3 columns, 3 opportunities. Once we get to our example, it's going to start making sense. So right now, I just need you to write, okay? So the additional property equality says if A equals B, and then I add C on one side of the equal sign, then I have to add C on the other side of the equal sign. So then A plus C equals B plus C. The subtraction property of equality says if A equals B, then if I subtract C on one side, then I have to subtract C on the other side of the equality sign. So if A equals B, then A minus C equals B minus C. This is the definition of that property. The multiplication property of equality says if A equals B, then A times C equals B times C. So if I multiply by C on one side, then I'm required to multiply by C on the other side. Now, the division property of equality says if A equals B, then A divided by C equals B divided by C. All right. Now, the symmetric property of equality is new. The 4 that we just talked about, you've been doing since algebra, okay? But the symmetric property, you've been using it. I promise you'll see in just a second. However, you didn't know it was called the symmetric property, okay? So the symmetric property says if A equals B, then B equals A. What happened here? What did we do? We switched it. Very good, Haslan. So, for example, here's where you see this all the time. You might solve an equation. You notice Miss Elliott doesn't do this. I don't switch 5 equals x into x equals 5, even though they're equivalent. I just don't switch places because, oh well. But the property that allows this to be possible is called the symmetric property. Now, the substitution property could have been written a little bit better, but I ain't tripping. It says if A equals B and A plus 3 equals C, so this could be any random number. This number right here is arbitrary. So then B plus 3 equals C. So what happened here? What happened here is everywhere I saw an A, I was allowed to put what it's equivalent to. I was able to plug in my B. Plug in my B. So when we do substitution, that's plug in and we use parentheses. So let's remind us about ourselves about that. We didn't use parentheses here because there's nothing multiplying, but let's remind ourselves that substitution is just called, in layman terms, plug in, and we're going to put it in parentheses. All right, transitive property. This one is brand new. Substitution is not new. We've been doing that for quite some time, okay? But transitive property is brand spanking new. And it says if A equals B and B equals C, then A equals C. What is happening here is we are cutting out this middleman. So we'll look at some more examples. I'm not really expecting this to make a ton of sense right now. But here's another way to look at this. If two things equal the same thing, then they equal each other. All right, that's transitive property. Now, we could put something in this box. I'm going to draw it, but obviously y'all know I'm drawing it with my pointer, so you don't have to draw it. This is a train. It's not the best train, but it's a train. And the reason why we draw a train here that helps people out is there's a train that starts in Denton and eventually ends up in Dallas. But where does it stop in the middle? Anybody know? Stops in Carrollton. And so, train in Denton, stops in Dallas. You have to get off the train in Carrollton and get on a different train in Carrollton that takes you the rest of the way. But what the transitive property does, it cuts out that middle stop in Carrollton. It says, we don't care about that. We're going to Dallas. So if you want to draw a train, draw a train. I'm not going to just because I don't think it's the best little example, but it helps some people's brain. So the reflexive property says, if A exists, then A equals A. Me equals me. I do want y'all to put right here, if A exists, then A equals A. So, quick question. It's a good question. Up until now, all of our definitions have been written as if-then statement. What do we call an if-then statement? A conditional statement. Very good. Thank you. that one deserves a piece of candy. So, it's a conditional statement. All of our definitions. And so, our next one is just an example, and it is the distributive property. Everybody say distributive. Thank you. So, the distributive property says if we have A times B plus C, then we can distribute the A, and that will equal AB plus AC. And what operation are we doing? Someone other than our sweet girl Haslin. What operation are we doing whenever we distribute? Are we adding A, subtracting A, dividing A, multiplying A? What are we doing? Multiplying. Very good. And so then our last but not least says if, and then I do this wrong every semester, so let me focus, lock in. I need to read this in fluent geometry. And this does not say if AB equals CD. That's not what it says. If we're reading this in fluent geometry, this says if the length of AB is equal to the length of CD, then pause for dramatic effect. Let's clarify something. What are AB and CD if they have lengths? Segments. Woo! Good job. Here's a piece of candy. They are segments. All right. So if the length of AB is equal to the length of CD, then the segments are congruent. In geometry, in the world of geometry, lengths slash measurements can be equal, but objects, the segments themselves, can be congruent. So lengths and measurements can be equal, objects can be congruent. Don't get that mixed up. This is super important. Okay? So let's do one more column. We're going to do the examples now. And then we're going to try some practice on the back. And then maybe come back to the front. So what we're looking at right here are algebraic examples. Now I'm going to show my work for examples 1 through 2. Just 1 and 2. Because really, truly, when we do a proof, our work is hidden. Okay? So the steps I'm going to show in 1 and 2, we're not going to do for the rest. So let's recall. The addition property of equality says, if we add 7 on one side, then we have to add 7 on the other side, right? These 7s would cancel out, but my statement would be equivalent. And I would have 5x equals 30. We are not going to continue solving this. We just want an explanation, an example, a demonstration of the rule. So next, the subtraction property of equality says if I subtract by 5 on one side, then I have to subtract by 5 on the other side. We know that when we use our inverse operations, that these would cancel out and we'd be left with 6y equals negative what? 30. Thank you, Sebastian. All right, so now we are on multiplication property of equality. If m equals 3, then 4 times m is going to, it looks like we multiplied by 4 on one side, so we have to multiply by 4 on the other side. What's 3 times 4? Thank you, Jonathan. It is 12. All right. And so the division property of equality says if 15y equals 105. Then y equals, what did we do to get y by itself? Divide. And if I divide on one side, the division property of equality says I have to divide on the other side. And we get y equals 7. So the symmetric property of equality allows us to switch. If 5 equals 3x minus 1, then 3x minus 1 equals 5. Symmetric property allows us to switch. So symmetric, switch. They both start with an S. Substitution property. We have if 5x plus 3 equals z and x equals -2, then everywhere I see an x, what can I put there instead? -2. So then 5 times -2 plus 3 equals z. We're not going to continue to calculate what z is, but we are just demonstrating the substitution property. Our next example is transitive. If 4 plus 1 equals 2 plus 3, and 2 plus 3 equals 5, then let's cut out the middleman. 4 plus 1 equals 5. If these match in the middle, and then they both go away, that's transitive property. All right, if the length of AB exists, then AB would be equal to itself, AB. And what property is that, y'all? Just read it off the page. Reflexive. I want to hear everybody say it. What property did we just demonstrate? Okay, that was like 2 people. Okay, it's morning time. I'll give y'all a pass. All right. Distributive property. We are going to distribute this 4. To distribute this 4, we are going to multiply. And so we'll end up with 4 times x is 4x. And then 4 times -5 is -20. Preguntas. Do we have questions right now? Yes. Oh, up. Yeah. All right. So if the measure of angle ABC is equal to the measure of angle DEF, so the measures of 2 angles are equal. Si las medidas de 2 ángulos son iguales, entonces los ángulos son congruentes. If the measures of 2 angles are equal, then the angles themselves are congruent. Notice I use the nickname for the angles because we ain't got time for all that, right? All right. Flip your paper over. I'm going to provide so much scaffolding. I promise. In fact, if you want to keep your paper face front, I promise to leave this up here long enough for you to use the front so we can answer these questions, and then you can flip it over and write it down. All right? So, these examples that we're about to do, it says, name the property of equality or congruence, whatever, that justifies each statement. Name one of the 10 properties above that allows us to come to this final conclusion. All right, before we get into this, these are all 2-column proofs. These are what I was telling you about. They're just doing something, but providing the reasons and the steps, the explanation, justifying your work as you do your work. So, every 2-column proof has a side for statements, the conjectures that you're making, and then it has a side for reasoning, the properties or postulates or theorems that we have learned. So, first one. Oh, last thing. When you are reading a proof, it is so helpful to read your first line as if, and then either, for these ones, it's going to be the last line as then, but for longer ones, it will be the first line as if, and this next line will be then. If you read it like that to yourself, it's going to help you think. So this says if P is congruent to Q and Q is congruent to R, then P is congruent to R. So tell me, with this information to here, what happened? Oh, we got rid of the middleman. Very good. What property is that? Ooh, good job, Haslin. This is transitive property. And it's technically a property of congruence, so we're going to put POC for property of congruence, because you have a congruent symbol instead of an equal sign. All right, let's do example B. And then again, I promise to zoom out, leave it up there, give y'all time to copy it down. All right, this says if x plus 4 equals 3x, then 4 equals 2x. Y'all, what happened? Subtraction. Ooh, very good, Sebastian. Subtraction. This is subtraction, property of equality. Very, very good. All right. If x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. Any thoughts on what happened here? I will help you out. I'll give you a hint. This is a big hint, okay? If I have guns here, what is it? Not multiplication. Very good, Simona, maybe. Substitution. All right, this is substitution property. Everywhere they saw a y, they said, we don't want that. I'd like the x instead. And so they plugged in the x where there was a y. Substitution, property of equality. All right. I don't love this one because there should be a degree symbol right there as well. They just missed it. But if the measure of angle A is 45, then 45 equals the measure of angle A. What happened? They switched, right? And so what property is in lemma is switch? Do your best to try it out, sound it out. Symmetric, very good. Symmetric, property of equality. All right, we only have 5 minutes left. I'm gonna rapid fire for these last two. If JK equals PQ and PQ equals ST, then JK equals ST. What happened? They got rid of PQ. So this is transitive property of equality. All right, next. If the measure of angle S is 30, then 5 plus the measure of angle S is 35. What did they do? All they did was add 5 on both sides. So what we just did, these examples were like little baby proofs, right? We only had to provide one reason. But now we're about to do a big daddy proof. Okay? In the big daddy proof, we have to provide the statements and the reason. All of them. Not just one, all of them. Here we go. So this is what we call an algebraic proof. Our goal in this algebraic proof, it says solve the equation, right? Get x by itself. And then write the reason for each step. That's how you do proof. It's really simple. Solve it like normal. Don't show your work. And then you showing your work is actually giving the reasons. So the equation itself is always going to be your first line, your first conjecture, your first statement. And the first reason, no matter what type of proof you're doing, the first reason is always the exact same. What do y'all see here? What's always our first reason? Just read it. What do I have circled? Given. So we're given this equation, and it has x's on both sides. I taught y'all that when there's x's on both sides, what's our first step? We're going to do something with the smaller x. We're going to subtract the smaller x. So when we subtract the smaller x, that means we would subtract what? 5x or 3x? All right, when we subtract 3x from both sides, we would end up with 2x minus 18 equals 2. Why? What's the reason? Because we just did the subtraction. Property of equality. All right. If we want to get x by itself, we have to get rid of the neighbor. How are we going to do that? Add or subtract? It's already negative, so we have to do the opposite. So what are we going to do? Y'all, everybody? Somebody other than Haslin who's working so hard. Avery, what are we going to do? Thank you, ma'am. So we are going to add 18 on both sides, but we're not going to show our work because us showing our work is just saying, hey, the addition property of equality handles that. And when we add 18 to both sides, we end up with 2x equals 20. What is our last step to get x by itself? Divide. And so x equals 10. Why? Because of the division property of equality. Cool beans? All right. We're not going to have time to go back to the front, and that's okay. Promise, okay. If you need it, it is online. You can copy it down. But let's do our last proof. Solve this equation. So get z by itself. Sometimes our variables are not x, they're just a different letter, and that's okay. We need to get z by itself. If you are familiar with the thing called PEMDAS, you know that the very first thing we need to do is get rid of those parentheses. So, how do we get rid of the parentheses? What is that called? Distribute. We're going to distribute. So when we distribute, we end up with 55x minus 27z minus 36 equals 64. This is the distributive property. Now, the next thing that we're about to do is hopefully going to expand your mind. I said that the reasons earlier, I did mention this, okay? They're the 10 properties we learned, plus postulates and theorems, and a few other things, okay? I'll get you a list. We'll talk about it. But our next step, y'all know what's happening, and I'm going to tell you, is not subtraction. But it's something we have not talked about today. What did I do? I didn't really get rid of 55z. What I did was, let me say that. What did I do? Thank you, man. I combined like terms. Combine like terms. That's a valid reason. It wasn't on our list, but it's completely valid, and you will use it. So now we're going to start solving again. Inverse operating. Okay? We got a negative 36. We got to get rid of it. So what are we going to do to both sides? Yes. I missed that negative on the 64. Please add that. But yes, we are going to add 36 to both sides. When we add 36 to both sides, we get 28z equals negative 28. Why? Because of the addition property of equality. What is our last step to get z by itself? Divide. We're going to divide by 28 on both sides, and we get that z equals negative 1. Why? Division property of equality. So that concludes our notes for today.